Good morning, Year 11. So a nice quick video today, just a little bit of trigonometry. So you know the question in your exam is trigonometry when it's a right-angled triangle and you either have or want an angle. So this is definitely trigonometry because it's a right-angled triangle and we want the angle. So as soon as we identify it's trigonometry, we have to think of that special word, SOHCAHTOA, which I'm going to write at the top of my page. SOHCAHTOA. So we identify it's trigonometry and we're thinking about SOHCAHTOA. So once we're on the right train of thought, we're going to look at our right-angled triangle and decide whether we need SOH, CAH or TOA. To do that, we're going to label what we have. Opposite the right angle is our hypotenuse. Next to the two angles, the right angle and the angle that we want, is called our adjacent. Two lengths, A and H. Is that SOH, CAH or TOA? Well, the only one that contains the A and the H is CAH. And I'm going to write that out. Times sign in the middle, and then a divide sign above the C and the H. So CAH, it's got to be our CAH triangle. Because it's the angle that we want, I'm going to put a little cos to the -1, just so that I remember I'm trying to find the angle. I need my inverse cos. So circling the two that we need to use, because we want to find the angle, we circle the other two. And let's write it out a bit neater now. So cos to the -1 of the adjacent, which is 3, divided by the hypotenuse, which is 8. And then we're going to pop that into our calculator. So because we want the inverse cos, we're going to do shift cos. Now you can use your fraction key. Just going to get the lighting a bit better if I can. So use your fraction key here, or you can use your brackets, and then we're going to do 3, which is the adjacent, over 8, which is the hypotenuse. So shift cos 3 over 8, and then that's round that off to 2 decimal places, so 67.98. And we're talking degrees. There we go. Okay, let's try our next one. So it's a right-angled triangle. We know it's trigonometry because we have an angle involved. Label what you have. So the side that we have is this one here, which is next to the two angles, so that's the adjacent. We're trying to find this side here, so now we're going to label what we're trying to find. Opposite the right angle is the hypotenuse. So C and A. The one that involves the C and the A is CAH. So let's write out our CAH triangle. For this one, we're trying to find the hypotenuse. So I'm going to circle the other two letters. And that tells me exactly what I need to do. To find H, I need to do the adjacent divided by cos of the angle. So X is the hypotenuse that I'm trying to find. A, which is our adjacent, divided by C stands for cos, and whenever you write cos, you've got to write the angle. And let's pop that into our calculators. 25, we can use our division sign, make our life a bit easier. Divide by cos 40, and rounding that off to 2 decimal places, 32.64 centimetres. So this one, we're told to work out the length of RT. Here's R and here's T. So we're trying to find this length here. We have this, which is sitting opposite the angle we have. So that's called the opposite. The side that we want is sitting next to the two angles. So that is our adjacent. So which one contains the O and the A? So, ka, or toa? The O and the A is in toa. So let's write that out neatly. T-O-A. And let's recall what we're trying to find. We're trying to find R to T, which is the adjacent. So I'm going to circle the other two letters, O and T. So to get the adjacent, which is labelled as RT, we need to do the opposite, which is 14, and divide that by tan 53. Okay, let's pop that into our calculator. 14 divided by tan 53. Okay, 10.55 centimetres. And I'm just going to tidy that up. In your exam, you might want to cross it out and rewrite it if you make a little mistake there. Okay, on to our next one. Now we're given some information on this one that tan x equals 0.6. So this is possibly going to be on a non-calculated method. So I'm not going to use my calculator for this one. So I know tan of x equals 0.6. So a bit of information we've been given that we're going to use in a minute. We need to work out the length of BC. And BC is this length here. So we've got an angle we're going to need to, we're going to use this angle, but we have the angle because we know tan x is 0.6 and we have this length here and we need to find BC. 8 is the adjacent because it's next to the two angles and we're trying to find the opposite. So O and A. So, ka, toa. The one with the O and the A is toa. So let's set that up. T-O-A. And we're trying to find the opposite. So I'm going to circle the other two letters. So we need to do tan of the angle times the adjacent. Now I don't know the angle, but what I do know is tan of the angle equals 0.6. So I can put 0.6, which is tan of my angle, and times that by 8. And in a non-calculated paper, they're also testing your decimal knowledge here. We need to do 6 times 8, and 6 8s are 48. So multiplying 0.6 by 10 gets us 6. So now we need to divide 48 by 10 to get us 4.8 centimetres. And just see if that seems reasonable. This length here is 8 centimetres. Although the diagrams aren't ever really drawn to scale, it would indicate we're looking for a number smaller than 8, which 4.8 is. It does seem reasonable. So press pause and have a go at your other answers and then press play when you're ready. So your first one, you're actually using sine because you are trying to find the opposite and you have the hypotenuse. So sine 36 times 7, you should get 4.11 centimetres. Question 2. You have the opposite and you have the adjacent and you want the angle. So we're looking at tan to the minus 1 and we're circling the O and the A. So shift tan, your tan to the minus 1 of the opposite, which is 9 divided by 20. We get 24.23. Okay, non-calculator for this one. We know that sine 30 equals 0.5. We're trying to find the opposite and we have the hypotenuse. So that means we're going to do sine times the hypotenuse. So sine 30, we know sine 30 is 0.5, so 0.5 times 16, which gets us 8 centimetres. For this one, you have to use trigonometry twice. You need to first of all find the side that is opposite the angle. So we're looking for the adjacent as well. So we're looking for using our TOA triangle. Because we want the opposite, we're going to times. The tan 50 times 5 is 5.96. So that is what this length here is. We're then going to use this because this now becomes the adjacent. And then we're trying to find the opposite. So we're going to use the same. We're trying to find the opposite. So we need to do tan 38 times our adjacent there of 5.96. You should get 4.66. Similar with this one here. We first of all need to find the side opposite 65. So that's going to be tan 65 times by the adjacent of 3, which gets you 5.89 centimetres. That's this length here. We then are using this length here to calculate this angle. Now on this triangle, this is actually the adjacent. So I've crossed out the O and now turned it into an A for the adjacent. And 10 is the hypotenuse. So we're now working with A and H, which is our CAH triangle. CAH. We want the angle, so I'm going to circle the A and the H and make sure that I'm using cos to the minus 1. So cos to the minus 1 of the adjacent that we just calculated divided by 10, we get 53.91, I think that was. And we're talking degrees for that. So 53.9 degrees. I will now set you guys some questions on MathsWatch. Thanks guys, have a good day.